Okay, the last problem is also going to be continuous. So the half-life of the drug Lortab in the bloodstream is about 4 hours. So you put Lortab in your bloodstream, it starts breaking down. It breaks down at a continuous rate. So every second of every minute of every hour of every day. So it's something that is constantly changing. Okay, now, I don't know what I'm doing here. So the model we're going to use is the initial amount times E to your rate of change times time. And it looks like time is measured in hours. Okay, so question A is how much drug is left in the bloodstream 2 days. So let's go 48 hours after a heavy dose of 15 milligrams. Okay, so before I do anything, I really need to know what this K is, the percent of its change. And we're going to use this idea. The half-life is 4 hours. If you know that the half-life is 4 hours, we can figure out the K. So you make up your own initial amount. The initial amount does not matter at all. So if I say the initial amount was 100 milligrams, I know the half-life, it's going to end up at 50 milligrams. So I'm going to use 150. You could use 15 and 7.5. It doesn't matter. You'll get the exact same answer. As long as what you start with and what you end with, you got to end with exactly half of what you start with. Okay, so I'm going to times that by E. And the K is what I don't know, but I do know that for it to cut in half, it takes 4 hours of time. So there's your equation. And you can use 15 and 7.5. You'll get the same answer. Because when you start solving for K, you undo first this multiplication. So you divide this side by 100. You divide this by 100. And you're going to get 50 divided by 100. Whatever you chose, we are all now at the same. We're at 0.5 equals E to the 4K. Now I gotta solve for K. It's in an exponent. I gotta undo the base. The only way you can undo a base is a log. So my next move, I'm going to go log in base E of 0.5, and that equals 4K. And this is all calculator. Log in base E of 5, do the natural log of 5. That has to be done on the calculator. Get a decimal. And we should have this. So the natural log of 5 is a negative 0.693147 equals 4K. So now I just got to divide by 4, divide this by 4, and my K is a negative 0.17327. So in percentages, it's like pretty good amount. That's a negative 17%, 0.32. So it's changing 17% each hour. Okay, so let's use that going forward. Now that we found the K, so in a 4-hour period, your initial amount gets cut in half, and if you know that, we can use that we figured out it's going about 17.3% each hour. So question A, how much of that initial 15 milligrams is going to be left in your bloodstream after 2 days, so quite a few hours. K. Gosh, I don't know what's happening. So, the end amount, that's what we're after. We don't know. The initial amount, we do know. You took a dose of 15 milligrams. We're going to times that by E to the negative 0.173287 times 48. So this one's straightforward. Type that in your calculator and that should give you in milligrams how much is left in your bloodstream after 2 days. So 15 times E to the negative 0.17. There's not very much. It is 0.003662. There's a trace of it though. So it takes days for that stuff to totally flush out of your system. Okay, question B. When will the amount of Lortab decay to 35% of its original amount? So 35% of its original amount was 15. So I'm going to change the percent to 0.35 of is times. So 35% of 15, just do 0.35 times 15. And they want to know 35% is going to be 5.25 milligrams. So how many hours are you going to have 5.25 milligrams of Lortab in your bloodstream? So 5.25, that's actually the answer. So that's what we're going to plug in for the Y. So we're going to go 5.25 equals your initial of 15 times E. You know your rate of change was negative 0.173287 times. Now this time the time is the unknown. That's what we're trying to find. So we'll just call that X or T or whatever you want. But the variable is in your exponent. So we're going to have to undo this equation. The only way to undo the base is with a logarithm. So first let's get the base by itself. Let's undo this times 15. So let's divide this side by 15. Let's divide this side by 15. 5.25 divided by 15. Okay, we got this. We have got 0.35 equals E to the negative blah 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 times X. Okay, now let's morph it. Let's change it. Let's undo the base of E. The only way to do that was with a log. So now we're going to go log in base E of 0.35 equals this K times T. So it's negative 0.173287 times our time, which is unknown. Now you have to use your calculator to change this to decimal. So the natural log of 0.35. So we've got this changed to a decimal, and it is a negative 1.04982. And then we've got the negative 0.173287x. So now to solve for x, all you gotta do is undo that times. So divide this side by that number, divide this side by that number, and you should get something close to x equals 6.05, 829, so a little over 6 hours. And you'll have 35% of the original amount. So 4 hours you'll have 50% of the original amount. A few hours later you'll have 35% of the original amount. Okay, so let's look at C. Let me erase some stuff here. C. How long after the initial dose is it going to take to decrease to 2 milligrams? So C is almost identical to B. B might have been a little bit harder because you had to find 35% of 15, which was 5.25, but now they're giving you the 2, so they just gave it to us free and easy, so we're going to plug that in for Y. So 2 milligrams equals the initial 15 milligrams times e to the negative 0.173287, and x is your unknown. So go ahead, solve that one on your own just like we did B. Compare your answers, make sure you got the same thing. Then go ahead and start on the homework.